Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 21st video in the Introductory Programming in Java full course, and the 4th video of Lesson 4, Looping Structures in Java. So far we've covered while loops, do-while loops, looping patterns, and input validation loops. In this video we're going to talk about nested loops, loops that are within other loops. Let's get right into it. So first, what is a nested loop? You can embed any structure that we've learned so far in another structure. So for example, you can put a switch statement inside an if, or an if in a while, or a while within a while. So that is what nesting means. Think of those Russian nesting dolls. It means a structure within a structure. A nested loop usually means two or more loops that are immediately nested within each other to traverse or produce nested data. We're going to start with a familiar example, an analog clock. A clock is a good visual metaphor for a nested loop, and you can see it has an hour hand, a minute hand, and a second hand. I've sped it up. Now each of the hands moves all the way around the clock, but they do it in a nested fashion. The second hand completes its rotation around the clock before the minute hand can move 1 minute, and then the second hand completes its rotation again before the minute hand can move another minute, and this repeats. The minute hand is rotating around the clock. It's just that the second hand completes a full rotation before the minute hand can move one increment. It's the same for the minute and hour hands. The minute hand must complete a full rotation around the clock before the hour hand can move one increment. We can program a simulation of this. We're not going to program a real clock. Java has a time package that we could use for that. This program, called clock simulation.java, will just print minutes and seconds. I'll run it. And you can see it prints all of the minutes and seconds in 1 hour from 0000 through 59:59. If I scroll through the output, you can see it prints all of the seconds in minute 0. And then once we've reached second 59, we increase to minute 1 and then print all of the seconds in minute 1. And this continues through the end of minute 59. Looking at the code, I've put some comments in that identify the lines of code that control each loop. If you look at each of these loops individually, I think you'll notice they're ordinary and simple loops. The inner loop is on lines 18 through 22, and it's simply an initializer, seconds equals 0, and then the loop header with test, while seconds less than 60, and then inside the loop a print statement, and then the updater, seconds plus plus. That is wrapped with the outer loop. On line 14, the initializer, minutes equals 0, and then the test, while minutes less than 60, and then after the inner loop, the updater, minutes plus plus. Notice that the print statement prints both loop control variables, minutes and seconds. So we set minutes to 0, test that it's less than 60, it is. So we go into the outer loop body and set seconds to 0, then test that seconds is less than 60, it is. And then we print minutes and seconds and update seconds to 1. We then go up to the loop header on line 19, while seconds less than 60. Remember, that's how a loop works. We can't get out of the loop until the test is false. So we'll stay in this inner loop until seconds is finally 60, when the test will be false. And then we'll proceed to the first line after the inner loop, the updater for the outer loop, minutes plus plus, and we go back up to the top of the outer loop. The value of minutes is now 1, so the test is true, and then the inner loop starts all over again. We set seconds to 0, so that loop will execute its full 60 times before we update minutes again on line 23 and go back to the top of the outer loop. You might walk through this a few times in the debugger to get used to the pattern, but before you do that, I'd change the tests to check for a smaller value than 60, such as 3 or 4, so you don't have to step through 60 iterations of the inner loop. Let's look at another example, this time iterating over a string. Recall that strings have the methods char_at to get a character at a specific index, and length, which returns the length of the string. We use these two methods when we're looping over a string to process the individual characters. This program is called printwords.java. I have here a string called text, which is a quote from Martin Luther King Jr., which begins, "I have the audacity." To simplify the program so we can focus on the loop, I've removed all punctuation and replaced the period at the end of the quote with a space. So the quote is composed of words separated by, or delimited by, spaces. What I want to do is print this quote with one word on each line. So we want to have one loop that accumulates characters until it reaches a space. So it would accumulate the I and reach a space, and that would be one word. And then it would accumulate HAVE and reach a space, and that would be the second word. And then it would accumulate THE, etc. You can see that we need another loop outside of that loop if we want to accumulate and print all of the words, because we want to keep gathering each word until we've reached the end of the string. So we want an outer loop that loops until we reach the end of the string, and an inner loop that loops until we reach a space. You can see those two loop entry conditions on lines 21 and 23. The outer loop is while I less than text.length, and this is like other loops we've seen that iterate over a string. You can see on line 18 I've defined that index I and initialized it to 0. And on line 28 we increment I so that each time through the loop we're examining the next character in the string. For the inner loop entry condition, it's while text.char at I does not equal a space. So the inner loop iterates until the character we're looking at is a space. In other words, it iterates through a single word. Notice that we have to increment I in this loop as well, otherwise we would always be looking at the same character and we'd have an infinite loop. To accumulate the word, I'm using system.out.print text.char at I. This will put the current character in a buffer. Depending on development environment, the print command might put the value you print in a buffer, or it might display it in the console, but without a new line after it. So what we print will get held or displayed on the same line until a print line. In Eclipse, a print will display the string, but it will not put a new line after it. The print line is after the inner loop, after we've reached a space. When the print line executes, the buffer is flushed or cleared, and the word gets printed to the console. Or, if the text has been displayed, the cursor moves down to the next line at a print line. The loop control variable I gets incremented, so it's one character beyond the space, and control flows to the test on line 21. As long as there's still text in the string, we begin the inner loop again, accumulating a word in the buffer until we reach a space. Let's run it, and you can see it working. And it's printed the quote, one word to a line, as expected. Let's step through this one in the debugger and watch it work. I'll put a breakpoint on line 18, click the bug, and then choose Switch at the dialog box to switch to the debug perspective. By the way, sometimes I have students tell me the debugger isn't working. It just flies through the program. In Eclipse, you have to set a breakpoint before you debug. So if that happens to you, make sure you set a breakpoint. If you did set a breakpoint and it still happens, then the line with your breakpoint is never reached. Once we introduce structures that alter the flow of control, such as if statements and while loops, there will be lines of code that might not execute each time the program runs. If you set a breakpoint on a line you think is going to execute and it doesn't, that's good information for you. Set the breakpoint earlier and figure out why your line isn't reached during program execution. For example, if I had an empty quote, if text were an empty string, quote, quote, my loop code would never execute. Okay, so we've stopped at line 18, and we can see text is defined in the variables section. Let's step over line 18, and now we can see the variable I is equal to 0. And we're on the test for the outer loop while I is less than text.length, and we can see that text is much longer than 0, so we'll step over and go into the outer loop. And now we're on the test for the inner loop. We can see that text.char at 0 is the letter uppercase I, which is not a space, so we'll expect this test to be true, and we'll step over. And now we're on the print statement. And that placed our character I in the console. Now we're on the updater on line 25, I++. Let's step over. And we can see I has been incremented to 1. We can see by looking at our string that text.char@1 is a space. So the test on line 23, we're back at the test, will be false, and our inner loop is finished. Let's step over. We jump over the inner loop, and now we're going to finish the rest of the outer loop body, the print line, and we'll step over. And I++ will step over. And now I is 2, and we go up to the top of the outer loop. We still have a lot of string left, so when we step over, we go down to the header of the inner loop. Now char@2 is the H in have and not a space, so we'll go into the inner loop, and we'll step over the print, and now we see the H. It's on the next line because of that print line on line 27, which puts a line feed after each word. And now I is incremented to 3. We go back up to the top of the inner loop. Remember, the inner loop will need to finish executing before we can finish the outer loop. And we can see that char@3 is the A in have, so we'll go in, that prints, and I is incremented again. Notice that A is printed on the same line as the H. So if I keep stepping, we go into the loop 2 more times. Once for the V, and now we're printing the E, and now I is incremented again to 6, and the character at index 6 is a space. So when we go to the inner loop header, that test is false. The inner loop has finished executing. So we'll go down to the rest of the outer loop print line, and then increment I again, so we're 1 beyond the space, and then up to the top of the outer loop again. I suggest you step through this loop as well, and maybe make some changes to it. For example, what happens if there are 2 spaces between words? What happens if you use a different delimiter? What happens if there's punctuation in the string? Can you make it work with punctuation? When you're structuring a nested loop, you're looking for a pattern, as with most loops and even programming. You're looking for something that's repeated, that is itself repeated. Here, reading characters in a word is repeated, and reading the words is itself repeated. I recommend writing the inner loop and then wrapping that in the outer loop. There is sometimes some housekeeping you need to do before or after the inner loop, which is part of the pattern. For example, with this loop, we need to move the index beyond the space in the outer loop and print out the word. In the clock loop, we need to restart the seconds at 0. These are relatively simple loops, so often there's a bit more you need to do to get both loops functioning correctly. And as usual, I have included some auto-graded exercises in the description of this video so you can practice with the video code, and the code has been uploaded to my GitHub repository. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.